grades, high grades, high grades, high grades.
Hello, beautiful human beings of the internet. I am Rachel.
And I'm Aljoy, and we're here because we made a vlog about how we use compound microscopes because we're bored and we're medical biology students.
Exactly.
And so we're gonna show you the video. Here's it. Okay, hi guys. We're joined by
Our friend Matt.
yes, and we're gonna show you the microscope.
Come on, let's go. Let's go.
So we're here in the stock room.
So as you can see, there are different types of microscopes
Yes,
that
and-
we use in this subjects.
Different subjects, biology subjects.
Yes. So today we're gonna show you how to use it and what are the parts of it.
Okay.
Hi. So we're here in the cell and molecular biology section room, and Matt here will demonstrate how to use the microscope, and we will show the different parts of it, and then later we're going to place a slide so we can see the features of this.
So, the main parts of the microscope are, first is the eyepiece, this one is the neck, the base, the light source, the stage, this one is the stage adjustment knob, this one is the coarse adjustment knob, and the fine adjustment knob. The most important part of the microscope is the objectives, which are of 4 kinds. The objectives of the microscope are 4 times. First is a scanner, which magnifies the object 4 times. Next is the low power objective, or LPO for short, magnifies the specimen 10 times. The high power objective, HPO, magnifies the specimen 40 times. And the OIO, which we use OIO, which stands for oil immersion objective, that magnifies the specimen 100 times.
So now we know the parts of the microscope. We're gonna show you what it looks like this,
With the slide.
this thing, specimen. It's called specimen, guys. Okay.
The slide.
So it usually looks like this, out of focus, and our friend here, Mac, will use the fine adjustment knob to make it clear. Like so. As you view the specimen and you switch from low to high magnifications, you view, you focus on one portion of the specimen closely.
The closer you look, the less you see.
To our friend Mac here for showing us how to use the microscope and the parts.
Yes, of the microscope.
Yes.
Now you know.
So we're back, and we've been talking. Then we've decided that we're gonna look for more friends for you guys because we want you guys to know more
about microscopes.
like its history, like who invented it, how it was used,
When was it first used?
Yes, and what was the thing viewed first.
Yeah.
Because we love you guys.
Yeah. That's how much.
That's how much we love you guys. We're gonna look for friends. So we're gonna meet up with Jade, our friend, who's gonna relate physics with microscope.
Yeah. So
And we're on our way.
let's go.
So Jade, since you know a lot of things about physics, since you got the highest grade midterms, can you explain?
Elaborate.
Elaborate how
Explain further.
microscope is related to physics. How light wave.
You're here. It's been a while since we talked, and now I've got a lot of questions about how physics works, with microscopes, how our is formed, and can you explain to me
Good afternoon, Rachel and Aljoy. As of this moment, I'm going to discuss about the history of the microscope. Before the invention of the microscope, there were magnifying glasses. They magnify to about 6 to 10 times. They were used by scientists for observing on trees, since they were initially called tree glasses. During the 1590s, two Dutch spectacle makers Zacharias Janssen and his father Hans Janssen discovered the first compound microscope. They put several lenses in a tube, and the object near the end of the tube appeared to be greatly enlarged, much larger than any simple magnifying glass could achieve by itself. Next, a Dutch scientist and one of the pioneers of microscopy named Anton van Leeuwenhoek was the first man to make and use a real microscope. It magnifies to about 270 times. Robert Hooke's famous Micrographia is published, which outlines Hooke's various studies of the microscope. In 1878, a German optical scientist named Ernst Abbe invented a theory linking resolution to the wavelength of light. Then, in 1903, an Austrian-Hungarian chemist named Richard Zsigmond Lee invented the ultramicroscope, which allows for observation of specimens below the wavelength of light. An ultramicroscope is a microscope with a system of illumination that allows viewing of tiny particles. When the diameter of a particle is below or near the wavelength of visible light, around 500 nanometers, the particle cannot be seen in a light microscope with the usual method of illumination. The ultramicroscope system is based on light scattering, not light reflection. In 1932, transparent biological materials were studied for the first time using Dutch physicist Fritz Zernike's invention of the phase contrast microscope. The phase contrast microscope is widely used for examining such specimens as biological tissues. It's a type of light microscopy that enhances contrasts of transparent and colorless objects by influencing the optical path of light. The phase contrast microscope is able to show components in a cell or bacteria, which would be very difficult to see on an ordinary microscope. 6 years after that, in 1938, comes the electron microscope, developed by Ernst Röska, who realized that using electrons in microscopy enhanced resolution. An electron microscope is a microscope that uses a beam of accelerated electrons as a source of illumination. Because the wavelength of an electron can be up to 100 times shorter than that of visible light photons, the electron microscope has a higher resolving power than the light microscope and can reveal the structures of smaller objects. Because the wavelength of an electron can be up to 100 times shorter than that of visible light photons, the electron microscope has a higher resolving power than the light microscope and can reveal the structure of smaller objects. A transmission electron microscope can achieve better than 50 picometer resolution and magnifications of up to about 10 million times. Transmission electron microscope can achieve better than 50 picometer resolution and magnifications of up to about 10 million times, whereas most light microscopes are limited by diffraction to about 200 nanometer resolution and useful magnifications below 2000. Finally, in 1981, 3D specimen images became possible with the invention of the scanning tunneling microscope by German and Swiss physicists Gerd Wienig and Heinrich Rohrer. That's all for the history of the microscope. Thank you and stay good always.
So now we know a lot of things about compound microscopes. We're gonna end this video because we know you're so bored and you're so sick of our faces.
Yeah,
you know.
sorry.
So don't forget to like, subscribe, and comment.
Comment on what you want to see on the next video. So,
You know, don't forget to hit the like button. So.
Turns out the wrong side of the bed is the right side. Get out of bed.